Okay, so remember, all of the following mean the same thing. So suppose we have some polynomial p of x, polynomial function, and c is a number. If p evaluated at c is equal to 0, that means that c is a 0. And that's the same thing as saying that x minus c is a factor. And if c is a real number, then that means that the point c comma 0 is an x-intercept on the graph. Okay, so this is something that we have to remember. Also, the remainder theorem says that p evaluated at c is equal to the remainder when we divide p of x by x minus c. All right, so if we put all of this together, we can solve different types of problems. And there's many different ways this zeros could be asked of us. So one question that we could be asked is x minus 1 a factor? Is x plus 2 a factor? Or is x minus 2 a factor? So what we have to keep in mind is what I just cleared. If c is a 0, that means exactly the same thing as x minus c is a factor. And all of those mean the same thing as p evaluated at c is equal to 0. So those three things mean the same thing. They're not asking us about any x-intercepts, so these are the relevant things to remember. So is x minus 1 a factor? That's the same thing as asking, is 1 a 0? And of course, that's the same thing as asking, is p evaluated at 1 equal to 0? So if the answer to one of these is yes, the answer to all of them is yes. If the answer to one of these is no, the answer to all of them is no. This is the one that's easiest to find out. What is p evaluated at 1? Well, it's going to be 1 cubed minus 8, which is 1 minus 8, which is negative 7. So is p evaluated at 1 equal to 0? No, it's not. It's equal to negative 7. So therefore, is 1 a 0? No, it's not. Because that breaks the definition of what it is to be a 0. And if 1 is not a 0, x minus 1 is not a factor. So the answer to that one's no. Now these are easiest to see when you don't have to rewrite anything. On this next one, is x plus 2 a factor of p? Well, you're going to have it in the form of x minus something. So I'm going to rewrite x plus 2 as x minus negative 2. So is that a factor? Then the question is the same as, is negative 2 a 0? Because if negative 2 is a 0, then x minus negative 2 is a factor. And is negative 2 a 0? That's the same thing as, is P evaluated at -2 equal to 0? And if one of these answers is yes, the answer to everything is yes. If one of these answers is no, the answer to everything is no. So this is the easiest one to see. What is P evaluated at -2? Well, if the negative sign is inside the parentheses here and the power is odd, then we keep the negative sign. If the power is even, we lose it. So this will be the negative of 2 cubed, which is -8. So P evaluated at -2 is equal to -16. So is P evaluated at -2 equal to 0? The answer to that is no. Therefore, -2 is not a 0. Therefore, x minus 2 is not a factor. Okay. And then for this last one here, is x minus 2 a factor? Well, that's the same as saying is 2 a 0? And is 2 a 0? That's the same thing as asking is P evaluated at 2 equal to 0? Let's see what happens. So is P evaluated at 2 equal to 0? The answer to that is yes. Therefore, that's the same thing as saying 2 is a 0. And if 2 is a 0, that's the same thing as saying x minus 2 is a factor. So that's one way a question could be asked of us. We could have something like this. Find all the zeros. Well, from the list of things that mean the same thing, if C is a 0 and C is a real number, then that means the same thing as the point C comma 0 is an x-intercept. So if I can find x-intercepts, I'll have located real zeros. Okay. So let's look at the graph of this. I'm going to come up here and I'm going to put 15x cubed minus 108x squared plus 183x minus 90. And I'll start with a zoom 6. Okay, and now I might want to refine that. I'm going to come here to Window. And now let's see what's happening. Okay, so it definitely looks like I've got an x-intercept here, which is at 5, and I have an x-intercept there, which is at 1, and then a little bit bigger than 1. But if I go back to the standard viewing, you can see that there's no x-intercept at -1. So there's -1. There's no x-intercept at -1. So -1 is not a 0. So I can rule out that pick, and I can rule out that pick, because -1's not an x-intercept, so it's not a 0. Now, again, that one there is going through at 5. 5 is an x-intercept, so 5 is a 0. And this does not have 5 anywhere in it. So this is what by process of elimination, my choices would be. So it's easy to see 1 and 5. 6/5 is just slightly to the right of 1. And again, if we choose that window wisely, let's see what's going on. Okay, here's 1, and it goes through 1 and comes up and then goes back through. And so we have 1, and then we have something slightly bigger than 1. And 6/5, well, 1 is 5/5, and 6/5 is slightly, so that fits. Okay. So this is an instance where your graphing calculator does give you the picture. You can use it for multiple choice. Let's look at this one. Okay. Find all the zeros. Okay, now since it has degree 3, I'll have 3 zeros if I count any repetitions, the number of times they're repeated. So let's see what's going on with that one. Let's get our calculator back up. And let me click here and clear that. So we have x cubed minus 6x squared minus 2x plus 12. And if I start with a zoom 6, okay, it looks like we have a 0, a nice 0 right there. And that looks to be around 6. But where would negative 6 be? Negative 6 is about here, and as you can see, there's no x-intercept at negative 6. So we do not have a 0 at negative 6. So I can rule out that one. And then you can see that there are 3 distinct zeros, because I have 3 distinct x-intercepts, and this is saying there's only 1 0, 6, and maybe it's been repeated, but that's not true because we have other zeros, we have other x-intercepts that are not 6. And then we should be able to tell the difference between B and D. We just take a better window. So let me go here and click on window. Let me take it from negative 3 to 7. And let me have that again from negative 1 to 1. And take that. And then I'm going to click on graph. Okay, so we've got an x-intercept at 6. But now let's look at the grid. There's 1 and there's 2. And this is going through something between 1 and 2. There's negative 1 and there's negative 2. And this is going between negative 1 and negative 2. So I do not have an intercept, an x-intercept at 2. Nor do I have one at negative 2 because it has those grid points there. And so I do have x-intercepts, but they're not whole numbers. And square root of 2 and the negative of the square root of 2 match, are a good match for that because square root of 2 is like 1.4 something. And that sure is matching up with where you would think they would be. Okay. All right. What if we get back to web work? Let's see. I've talked about these in another video. Okay. This is a matching game. So if we look at something like this one, it wants to know what a possible formula is. So you can see here, you have an x-intercept at -2. And so -2 is a 0. And so x minus -2 is a factor. And so x plus 2 is a factor. That's what x minus -2 is. And it touches and bounces back. So since it touches and bounces back, the multiplicity is even. So this is going to be raised to an even power. And then here we have 1, 2, 3 is, we get an x-intercept at 3. And so 3 is a 0, which means x minus 3 is a factor. And since it crosses through, the multiplicity is going to be odd. And so this is what we want. This has to be part of the formula, part of it. And so we're looking for x plus 2 to an even power times x minus 3 to an odd power. And if we get out of this window, so this is the one I'm trying to match with, A. And so this is what I want. That's what I should find to match up with A. And so if I come here to my selections, there's only one that has x plus 2 to an even power times x minus 3 to an odd power. And so for this one, I would think it would be selection A. So that's how you're supposed to choose those. You're not supposed to just put them in your graphing calculator and match them, because then you're not going to become expert at that, and you're going to need to be expert at that. Okay, this was done in another video. Okay, so I'm not going to talk about that one so much. Also, to get all of these, in the last video, we go through every single one of those. Okay, that you're going to have to put it in your calculator and see what the zeros are. Now, the degree is 4, and so this will have 4 zeros if you count any repeats, if that becomes necessary. It may or may not. Okay, so let me give you a problem. Okay. So suppose we're told that P of x has degree 5. And list all the zeros and number of times they are repeated, or include any repeats or repetitions. If you have the graph, and the graph looks something like this. Okay, so what are the zeros? Well, we can see that 1 is a 0 and it crosses through, so it will have odd multiplicity. So it's either repeated once or it's repeated 3 times. Right now I'm just going to have it repeated once. We can see that -3 touches and bounces back. So it's even multiplicity. So it's going to be repeated twice or 4 times or 6 times, yada, yada, yada. And 4 is a 0 because we have an x-intercept at 4. It touches and bounces back, so it has even multiplicity, so it's repeated an even number of times. So if I write down the number of times this is repeated, then the number of zeros, since it has degree 5, I should have 5 zeros, and this combination works out well if I include any repeats. So on some question, if it asks you for the zeros and you just write that, and you might get an error message saying you haven't written enough. Well, it wants you to include any repeats. And so how did I know that 3 was only repeated twice? It's even multiplicity. It could have been repeated 4 times. Well, if -3 was repeated 4 times, then I've got 5 zeros already, and there's no room for 4, and 4 is repeated at least twice. 1 is a 0. It has odd multiplicity, so it only occurs once, or it's repeated 3 times, or it's repeated 5 times, and so forth and so forth. If 1 had been repeated 3 times, then I couldn't get my numbers to add up because -3 touches and bounces back, so it's going to be repeated an even number of times. So at the very least 2, and then I've already got 5, and so I don't have any room to include the 4. So this is the only configuration that's going to work out. But if all of them cross through, so if the degree is 5, and you've got this sort of situation, and so we've got -4, -3, 2, 4, 5. Then what are the zeros? Well, I can see I have an x-intercept at 4, at -4, so -4 is a 0. I have an x-intercept at -3. I have an x-intercept at 2. I have an x-intercept at 4. And I have an x-intercept at 5. Now, since it crosses through on every one of them, it has odd multiplicity, so they're repeated once, or 3 times, or 5 times, yada, yada, yada. They can only be repeated once, because when I add all of these up, I have 1, 2, 3, I have 5 of them as they are, and the degree is 5. So I'm done with that. Okay. One more. Okay, what are the zeros? The zeros are where I have x-intercepts, so -3, -1, 2, and 4. But now -3 touches and bounces back, so it has even multiplicity, so it's repeated at least twice. But for the rest of these, it crosses through, so these have odd multiplicity. And so I think the -3 is repeated twice, and the rest of these only happen once. And now if I count my zeros, I get 1, 2, 3, 4, 5. Okay, and that matches there. Okay, so that should be enough to give you an idea. Oh, the only other thing I want to talk about is something like this. This is always a question on the final in one form or another. Okay. All right, so here P of x is divided by x minus 5. So if I'm going to set this up for synthetic division, it's x minus the number in the box. We don't care what the quotient is, but we do care what the remainder is. Now, the remainder theorem says that P evaluated at the number in the box is equal to the remainder. And so straight away we can see that 5 is not a 0. If it was a 0, then P evaluated at 5 would equal 0, but it doesn't. 5 is not a 0, and if 5 is not a 0, x minus 5 is not a factor. And that's matching with this one. Okay, this is if you put the wrong number in the box. Remember, it's x minus the number in the box. Okay, and the rest of them are wrong for different reasons. Okay, so I'm going to stop the video there, and that concludes everything we needed to know for that section.